So today we are going to continue with the problem to prove with the identities and the ratios of the trigonometry, right? So you can see the LHS is given as sin a plus cosec a the whole square plus cos a plus sec a the whole square is equal to 7 plus tan square a plus cot square a. Okay, so first we apply the a plus b the whole square formula. So sin a plus cosec a the whole square plus cos a plus sec a the whole square. So let me use the a plus b the whole square. So you will be getting an a square as a sin square a plus cosec square a plus 2 sin a cosec a plus here will become a cos square a plus 6 square a plus 2 cos a ck, right? So we know that we can compare and write that sin square a plus cos square a as a 1, right? And this cosec we can write as a 1 by sin, and this sign will be getting cancelled. The same for the 2 sec, we can write a 1 by cos, so that and that will be cancelled. Rest we having the cosecant square a and the secant square a. Let me see. First we will simplify this. Sin square a plus cos square a will get a 1 plus the same cosecant square a. So this we can cancel by 2 sin a into cosecant we can write as a 1 by sin a plus this I already added. So secant square a plus 2 into cos a sec we write as a 1 by cos a, right? So cos a get cancelled and sin a get cancelled. We will be getting it as a 1 plus cosecant square a plus this 2 into 1 is a 2 plus secant square a plus 2 into 1 is a 2. So here the 2 plus 2 plus 1 is a 5 plus cosec. So cosec square a plus sec square a we got. But the LHS you can see this is 7 plus tan square a by cot square a. But using the identities we can change this cosec a and sec a in terms of a tan and cot, right? So this will become a 5 plus cosecant square a we can write as a 1 plus cot square a, right? Plus 1 plus cot square a. And a secant square a is a 1 plus tan square a, right? So plus 1 plus tan square a. So obviously we got 7 also. So 5 plus 1 we get a 7 plus cot square a plus tan square, right? So 7 plus tan square a plus cot square a. So order have changed but that is the same. So RHS. So we have proved. So here we go for the next problem. So LHS is a cosec a minus sin a into ck minus cos a. So which we have to prove that equal to 1 by tan a plus cot a. So we need in the denominator. So let me change the sign in the 1 by cosec a. So we will get denominator and also the same as the cosec, and here also the cos we can write as a 1 by sec. We will get denominator in terms of the sec. So cosec a minus 1 by cosecant a into ck minus 1 by ck. So this we can do a cross multiplications. We will be getting in a cosec square a minus 1 divided by cosec a into here is a multiplier, it will become a secant square a minus 1 by sec a, right? So we know that cosecant square a minus 1 is equal to cot square a, right? We know the identities, right? Cosecant square theta is equal to 1 plus cot square a, but while we bring this here it will become minus 1. So we will be getting in a cot a, right? This cot we will be getting. So it's a cot square a divided by cosecant a into the same 6 square a minus 1 we will be getting it as an tan square A divided by sec A. So now we are going to rewrite these things in the terms of cot in terms of a tan. So cot we can write is the 1 by tan square. So there are tan square and then tan square will be get cancelled, right? So we can write 1 by tan square theta, denominator already there is a cosecant A into tan square A divided by sec. So tan square and tan square get cancelled. So we will be getting in a 1 by cosecant A into sec, right? So 1 by cosecant into sec is not our answer. So we need in terms of a division tan and the cot. So just let we take this to numerator. We will be getting a 1, so that means inverse 1 by cosecant A is equal to, we will be getting it as a sine, and 1 by sec we will be getting as a cos. So sine A and cos A. So we need in terms of the tan and the cot, right? So here the denominator is a 1. So instead of this 1, we can write a sine square A plus cos square A. Why we are doing, we need in the denominator. So instead of this, we are writing a sine square A plus cos square A, which is we are choosing that since it's related to numerators also. So sine A cos A divided by sine square A plus cos square A, right? So now we divide so in the numerator we need a 1. So let me divide this numerator with sine A and cos A, the same with the denominator. So we are going to divide sine A cos A on both numerator and denominator, so that we will get numerator as a 1, right? So sine A into cos A divided by sine A into cos A. Denominator we have 2 terms, so there also we get cancelled, right? Sine square A by sine A cos A plus cos square A by sine A cos A. So this numerator we got a 1, and denominator the square and this get cancelled, and the square and this cos get cancelled. So we get as a 1 divided by here the sine A by cos A, so which is the tan, and then we got our answer. So cos A by sine A, which is the cot. That is what we need, right? So which is equal to 1 divided by sine A by cos A is a tan A plus cos by sine A is a cot A, which is our RHS. So hence proved. Clear? So first thing, we have taken this cosec, the sign in terms of a cosec, since we need in the denominator. We tried with that, and in that we got it as an 1 by cosec A sec. So that we written in the sine A and cos A, since we need an answer in the cot and sine. So if we change this to sine and cos, it is very easy to get, and the denominator will be getting as a 1. The 1 we can rewrite as a sine square A plus cos square A, since that we can get the denominators, and numerator we need a 1. So we are dividing the both numerator and denominator equally with the sine A and cos A, so that there will be no changes in the fractions. So like that, if it is a 2 by 3, if you are dividing the both numerator and denominator by 1 and 1, there will be no changes, right? So if there is a 2 by 3, if you are going to divide the numerator by 2 and denominator by 2, so there will be no changes, right? So the 2 will get 2 by 3. The same method we used to divide the sine theta and sine A and cos A to both numerator and denominator, so that the numerator will become 1, and denominator we simplified and we got it as a tan plus cot A. So here we go for the final problem. 1 plus tan square A by 1 plus cot square A is equal to 1 minus tan by 1 minus cot A the whole square is equal to tan square A. So here is 3 things are given. So let me prove that we take this 1, 2 and let me the 3, right? So to prove 1 equal to 2, it's a little difficult, but so 1 equal to 3 is easy. Just we have to simplify. We will be getting a one single term. The same way we will prove the 2 and the 3 are equal, so that the 3 also will be equal. So let me choose a 1. so which is equal to 1 plus tan square a by 1 plus cot square a. So let me use the identities. 1 plus tan square a we can write as an 6 square a divided by 1 plus cot square a we can write as an cosec square a, and 6 square a we can write as a 1 by cos square a, and cosec square we can write as a 1 by sin square. This we have changed since we need in terms of the tan. So by this going to numerator we will be getting in a sin square, it's a not a theta. So sin square a divided by this cos square will comes to denominator, the cos square a. So sin square a by cos square a we will be getting as a tan square a, so which is equal to 3. So we have proved that 1 is equal to 3, right? If we prove that 2 is equal to 3, then the 3 also will be equal, right? So let me choose the second thing. It is given as a 1 minus tan a divided by 1 minus cot a the whole square. So let me change, don't disturb the square since we need in the answer is also square. Instead only we have to do the changes. So we can write as a 1 minus tan, we can write in the terms of a sin a by cos a divided by the denominator we can change as a cos a by sin a. So don't disturb the square since we need answer in the square. So we are taking an LCM, we will be getting in a cos a minus sin a divided by cos a divided by sin a minus cos a divided by sin a the whole square. So let me take this numerator and we will rewrite this. So this will become a reciprocal in the numerator. So it will become the whole sin a is multiplied with the whole numerator is a cos a minus sin a divided by, this will multiply here, cos a into sin a minus cos a. Clear? Still we have the square. So we know that the sin square a and the cos square a are tan square a. We got that. Only these things we have to cancel. So here you can see that plus cos a minus cos a, here is a minus sin a and is a plus sin a. Just by taking the negative outside as we done for the previous problem, we can take a negative here outside, minus sin a. So it will become a minus cos a and this will become a plus sin a divided by cos a into plus sin a minus cos a. So whole square still is there. So this get cancelled, right? So these things we have already in the one sum. I think you hope you know that, you recalled that. So 1 minus sin a by cos a the whole square. So sin a by cos a we can say it as a tan a. So minus tan a the whole square. So the square it will become a positive, right? So negative will become a positive and tan will become a tan square a, which is equal to 3, right? So here the 2 is also is equal to 3. Previously we proved that 3 is also is equal to 1. So that therefore 1 is equal to the second and it is also is equal to the third. So we have proved it. Clear? So just you prove which is very simplified one. So that will be easy. So trying to prove this to this will be difficult. It will be taking a more. So by this it will be easy, which is very simplified one. Just choose like that. Clear? And this thing we already used and we are going to use once again here, that we are taking the minus outside to make it both same. Thank you.